All right, so welcome everybody. Today I'm going to be talking all about the American Computer Science League, the ACSL, or actually I found out very recently that you're supposed to call it ACSL, like pronounce all the letters. I think that's kind of funny. So yeah, talking about the ACSL competition. Our agenda for today, I am first going to talk about just myself, who I am, and what my background is. I'm then going to talk about what is my experience coaching the ACSL. We're going to talk about the format of the competition. So yeah, we're going to talk about the format of the competition. Then we're going to talk about the various topics of the competition. So what might you expect to see there, just so that you can know, maybe what to study for or what to prepare for. We're going to talk about, what you can do to prepare the competition. And then we're going to talk about what an ACSL course might look like here at the ACSL. And then finally, we will open that up for a question and answer session at the end. So if you have any questions, feel free to ask at any time, raise your virtual hand, or I might pause for a little bit, just kind of at the end of each section. But also you can feel free to wait until the end. So I guess first off, I'm going to talk a bit about myself. I originally am from suburban Chicago. I live in Illinois. That is where I'm giving this presentation. So pretty much like nobody who interacts with Bay Coding Club is from the middle of the United States, except for me, but here I am. And programming has been my hobby basically since I was like 9. I got into making video games and making websites. And actually, I still do those things in my spare time, even to this day. I just was really into programming. I was totally self-taught. I figured it all out from the internet. And yeah, I just kept at it even through high school. And then eventually I went to college. I attended the University of Minnesota over in Minneapolis. And I majored, not surprisingly, in computer science as well as math. And I kind of bounced around what I wanted to do career-wise a few times. And I thought, maybe I wanted to be a programmer just because that's a very, reasonable job to pursue as a computer science major. Although I guess I found that, just for me personally, it was kind of lonely, honestly. I didn't like just kind of sitting, alone coding like in a cubicle. And maybe if you're in Silicon Valley, it might look a little different, but around where I live, that honestly is what it looks like. And to prove this, I took an internship job at Caterpillar. If you are familiar with them, they're more known, I guess, for making like construction equipment. I was actually working on train engines. So I helped to control or program the control panel that runs on Union Pacific and Canadian Pacific train engines, and a couple other of the major lines use that software. And somebody else. And just through that time, I discovered that's probably not really what I wanted to do as my career. And so I eventually decided that I wanted to pursue education. Actually, instead, I wanted to be a teacher. And so currently I am actually I am a graduate student at Wheaton College, which is a small liberal arts school that has like a few grad students basically. And they do an education. And so that's what I'm studying. I'm getting my teacher license. It's like a mile from my house. I can walk there every day. So that's where I'm at. And I actually graduated college last December. And so I spent the semester, like I had a gap semester. And I spent that gap semester basically teaching classes at Bay Coding Club. So I taught, a lot of Python classes and various coding. And also I was the ACSL coach, both for the our grade school and middle school teams. So yeah, that was my work experience. Did somebody say something or a comment? Okay. So yeah, that is my background. That's what I've been up to. So I guess I would also talk about my ACSL experience. So one moment, I'm gonna have to do that really quick. So last year, ACSL was actually a new program, and so it was we got it off the ground pretty fast, maybe compared to some of our other classes, and so it was a lot of sort of quick decision making, I guess, on our parts, and I would say that honestly, it really challenged me as a teacher. It was. Well, so first off, it was my first time teaching on a lot of the material there. And, further. It was my first time teaching on a lot of that material. And it was also my first time teaching like with a test at the end. And so, but it was a really good growth experience for me. And I had a really good time. Honestly, and it really helped me to improve as a teacher. And honestly, I had a really fun time teaching the class. I had a lot of good times with the students. Some stories that I like to tell, which were, I guess, both like sort of learning experiences for me and also like really funny, was, so with the elementary team, we were doing a review game and we had like a joke question at the end. That was, come up with how many different kinds of cheese you can name. And some of the students got really into it and listed off like 20 or 30 kinds of cheese. And so, that was like a big inside joke in our class after that. People were writing tons of code with the word cheese in it and stuff like that. And in our junior team, when we were preparing for the final competition, I remember like we had a time after class when some of the students just worked on making various spam bots to try to like see if they could, how fast they could write a bot that would submit messages to the Zoom chat and try to outdo each other. And I honestly still don't even really know how they were able to do that. But I guess, so why did I include these stories? Just to let you know that, like, I mean, like the competition, it's a real competition and it's serious and we take it very seriously. But also at the same time, I like to have fun in our classes. And that was something that, I just really enjoyed, my time teaching that. But despite the joking around and the having fun, the results at the end of the season, I thought were pretty decent. For the elementary team, we actually won first place in the league, and we had two people who were medalists in the final round. So we had a gold medalist and a silver medalist. And then in the junior team, we had actually a lot of people go to the final round as well. So, despite all this, we actually had a pretty good season record, honestly. So yeah, that was my experience coaching ACSL and, kind of the experience that I had for the last, 6 or 8 months when we were doing that. And yeah, so now I'm gonna dive into the specifics of the contest. So the contest is divided up into different divisions based on your age. So the two main ones that Bay Coding Club offers currently are, we offer an elementary team, which is for kids in elementary school, excuse me, and they also allow 6th grade, just in case, maybe your age is kind of on the border. And there is also the junior league, which is for middle school. And they also allow 9th grade in there. Again, if your age is borderline, basically. There are also 2 different leagues that are intended for high school, which are intermediate and senior. And senior is basically the same as intermediate, but just harder. And it really depends on like how much experience the kids have is what those different leagues are for. Currently, we haven't really been doing like a high school course here, but if there was enough interest, we certainly could get one off the ground. And then there's also the classroom division. I'm not really going to talk about it, but I figured I should bring it up in case you see it somewhere else. It's kind of a blend of a lot of different age groups, and it's really more intended for like, if in like a public school, a class wanted to enter the competition. Those are the different divisions. The contest among each of these divisions is held in 4 different rounds. So there are 4 different regular season contests, and they are all spaced out about a month, starting in November. So they have 4 weeks separating each of them from there. They do give you an extra 2 weeks for winter break, fortunately. So, no ACSL practice on Christmas, no worries. And so it's 6 weeks between contest 1 and contest 2. The contests are taken online, actually on a website called HackerRank. It's used mostly for, it's actually like a website that's used for doing job interviews for programmers, but the ACSL decided it actually works very well for their contest. So that's all done completely online. And then based on, the results of the 4 main contests, I'll talk about this a little bit later, you might qualify for a final round, which is basically, the people who place well can do the final round. The final round is also taken online, it's taken online. And the timing of the regular season contests, it's pretty flexible. It's actually like, there's basically a window of like a couple weeks and you can take it whenever you want. But the final round, actually, everybody has to take it at the exact same time. Well, I think that this is a little bit left over. The final round, a fun fact, actually used to be in person. So they used to say, oh, it's in New Jersey. And so we're all going to go to New Jersey. So as you can imagine, that would be kind of a headache to coordinate. But due to COVID, they moved that online. And so that was maybe a blessing for us because, it would have been really hard for us all to take the contest if we all had to fly somewhere. But, all of our students could participate. So those are the 4 different rounds of the contest in the final round. Does anybody have any questions so far, or I can move on? All right, I'm going to move on. So the scoring of the contests is a little bit confusing, maybe. So among the different categories, there is a 3-person division and a 5-person division. So there's elementary 3-person and elementary 5-person, and there's junior 3-person and junior 5-person. And what that means is that the team's score is determined by either the top 3 or the top 5 people in that team on each contest. So actually, your team can have as many people as you want. Our teams entered the 3-person division, but they each had 6 people on them. And this may be, and so, when we take the contest, 6 people take the contest, and then the top 3 scores would count. And actually, our teams were a little bit smaller than most. A lot of people had 10 or even 20 students, even just in a 3-person division. So I guess I was like, well, why wouldn't you do 5 at that point? I don't know. But that's how that was. So this is pretty commonplace. And so your team score is determined by your top 3 or top 5 scores. And then actually, the ACSL gives out awards not just for team scores, but for individual scores as well. So if you have a great regular season, even maybe if the other people on your team, don't do as well, you will be recognized for that. So yeah, you can have a good individual season. And the team results are based only on the regular season contests, so the first 4 contests. And the final round is entirely done for individuals. So what I mean by this is whether or not you qualify for the final round, this is completely up to the individual. So if your team does really good, but you do very poorly, then you do not get to go to the final round. And all of the placing in the final round also is individual. So team scores aren't accounted for that. So that is how that works. And then the contest itself is divided up into both written and programming problems. So the written problems are basically like math problems, but the topics of the math, it's not like topics that you would do in school, but they're topics that are related to computer science in some way. And we're gonna go over actually like what all of the topics are. So I'm not going to go into more detail until it's time for that. But yeah, they're multiple choice written down problems, and there's 5 of them, and you have 30 minutes to do the whole thing. So yeah, time is not necessarily one of the big factors. And every contest has a written section like this. There is also a programming section. So the programming section is not included on the elementary contest. So the grade schoolers don't have to do programming, but the other teams all have to do programming. And the programming problem is, it's actually one problem, but it's like one really hard problem. And you have 72 hours to complete it. And it certainly doesn't take all 72 hours, right? It takes, you know, an hour or 2 hours or something. But the reason why students get 72 hours is so that, you know, they have time to really think about it and, you know, maybe sleep on it or leave and come back. So just time isn't necessarily a problem for the programming problem. The programming problem is completed in Python. I think it's possible to do it in other languages, but everything that I have heard about it is that people do it in Python. It's like just a very, you know, comparatively easy language to use. And that's exclusively what we use at Bay Coding Club. Basically the way that it works is you have a number of test cases that you have to solve. So I guess what do I mean by that? It's sort of like your code might have like, they will give you a list of different possible inputs for your code. And for each input, it needs the correct output. And you will actually, like, you see what some of the inputs are and you see what the output should be. And so this helps to guide you. And you can even like test your code as you're writing it. So, you know, you don't have to be perfect about syntax and things like that. It will tell you about errors so that you can fix them. But that is like the format of it. And then the way that it is really scored is there's hidden test cases that you don't get to see. And your performance on those test cases that you don't know what they are, that determines your score. So that's the programming. That is the programming problem. And the topics for the contest, that's like kind of strange to describe. Basically, every year, the topics for all of the contests are the same for each contest. But each contest is different from all of the other contests. So what I mean by this is every year, contest 1 covers like number systems and recursive functions and things like that, and like reading code and some other things. And every year, contest 2 covers you know, prefix notation and like bitstring operations and reading code and things like that. And contest 3 covers the same thing every year, and contest 4 covers the same thing every year. So there's no overlap between the contests. And also you have a pretty good idea of what to expect as well. So this gives actually a pretty big advantage to repeat students, as you might imagine. So, you know, last year was our first year and it was brand new to basically everybody on our team. And so it's sort of exciting to think about, you know, what these students will be able to do, you know, the following year, basically, now that they've already had some of this under their belt. So yeah, that is basically the format of the contest. If anybody has any questions about this, please ask away. Otherwise, I will move on. All right. And so then I guess the next section is I was going to talk basically about all of the different things that you learn on the contest. Basically so that first off, you know what to prepare for. Maybe you can get excited about it and maybe think it's interesting. I don't know, hopefully. And also why it's valuable that you will learn that thing. Because the ACSL doesn't really test you on useless things. It tests you actually all on things that you can apply in some way. And that's something that I think is really nice. You have like a good, like tangible takeaway from the contest. So one of the first things, the thing that is taught on contest 1, oh, you know what? I blanked on something. So before I actually go into the different topics, I should note that the contests get progressively harder as you move up in age range, as you might guess. And so what that means is the older you get, the more stuff you do. So the first 4 topics are on all of the contests. And then I'm going to talk about some that are only on middle school and older. And then I'm going to talk about some that are only high school. So that's how it goes. So yes, so the following topics are on everybody's contest, grade school, middle school, high school, all of that. So the first one is number systems. So what do I mean by number systems? So when you were in kindergarten, or at least maybe when people are in kindergarten now, we learned to count things like, the number 132. We think that, well, the 1 represents like 100, and the 3 represents 3 groups of 10, and the 2 represents like 2 ones. And so you can kind of think about breaking it up like this. And so maybe you notice that, well, 100, this is 10 to the 2 power, and 10 is 10 to the 1 power, and 1 is 10 to the 0 power. And next would be like 1,000, right? Which is 10 to the 3 power. And there's really nothing magic about the number 10. We chose it because we have 10 fingers. We just like the number 10. But actually, you can do math in all sorts of different, with all sorts of different systems that instead of being 10, it might be some other number. And that would actually be called like the base of the number system. So, we say our number system is base 10 because 10 is the number that you do all of the powers with. But you also could do it in 2, 8, and 16. All of those have a lot of different uses in computers. So base 2 is actually better known as binary, which I shouldn't even need to say why that's important for computers. And base 8 and base 16 come up very frequently for representing data, actually. So there's that. And you might learn how to convert between different bases, and you might learn how to count in binary, and you might know how to add and subtract in different bases. Those are all some things that you would learn on ACSL. Yes, it's all useful in representing data on computers. And a joke that I like to tell in my class when we learn this is, well, when you first learn to add in binary, you learn that 1 + 1 is 10. So not exactly what you would initially think. So that's number systems. Something that is on the second contest in all levels is prefix, postfix, and infix notation. So to motivate this, I'd like somebody to tell me what is 1 + 2 × 5. Anybody answer this in the chat? Oh, I see somebody saying, for some reason, ancient people created a base 27 or 28 number system. Yes, that is correct. Actually, the reason why is that's like how many knuckles you have. So you have like 28 knuckles or something like that. And so that they could count at 28. I don't know why. Anyway, so I actually have multiple answers coming in. Some people are saying 11 and some people are saying 15. And I'm very glad because this kind of proves my point about why this is important. So you might say, well, first you do 2 × 5 to get 10, and then you add 1 to it to get 11. And some other people might say, well, actually, instead, you should do 1 + 2 first to get 3, and then multiply this by 5 to get 15. How do we know which one to do? Well, the answer actually is that order of operations. Yes, you might have heard of PEMDAS. Please excuse my dear Aunt Sally, stuff like that, right? You do multiplication first. But if you didn't have this trick, you wouldn't really know. It turns out that there's other ways of writing numbers that you don't even need to do order of operations. So for example, you could write this same expression like this, so that the operations go in the front. And it turns out there's actually only one way of understanding this expression, which is basically like, first you do 2 times 5, and then you do that plus 1. And I'm not going to get into all the details, but basically this way of writing numbers is called prefix. And there's also a similar one called postfix. And it makes it so that you don't need order of operations at all. So that, yeah, removes any ambiguity. In this contest, you would learn how to solve prefix and postfix equations like that. And you would also learn how to convert between prefix and postfix. Well, I guess I wrote infix and I didn't tell you what that is. Infix is just regular, so this is infix. So how to convert between these different expressions. This is like, I guess, not the most useful of all of the topics, but there's some programming languages where like literally all of the programming language uses prefix. So the common one would be Lisp, the programming language uses all prefix. So that's this number system. Boolean algebra is kind of is the topic of the third contest on all of the levels. So this has to do with basically doing logic expressions using true and false. So for example, I might say, you must be 12 years old or have parental permission to go on this roller coaster or something like that. That's probably not how they would have a roller coaster. Then this sort of begs the question, like, well, what are all the different combinations? Like, if you are 12 years old and you don't have parent permission, then you can go on. And if you are not 12 years old and you do have parent permission, you can go on. And there's these different combinations. You can actually make these expressions like even more complex. Maybe I could say, you must be 12 years old or have parental permission and have spent $5 on a hamburger before riding the ride or something like that. And you can get these really complex expressions. And it turns out you can actually do a lot of interesting algebra with them to simplify them down and figure out, like, really get at the heart of what they mean, basically. And so, for example, I wrote, some of the various Boolean algebra identities over here. These are various properties that are true about Boolean algebra that you will learn. And you get to learn about tautologies, which are things that are always true, and contradictions, which are things that are always false, and how to simplify things. These are some things that you might learn about. Yeah, and this is totally useful actually for programming because it turns out when you code, you're going to write a lot of statements that are like this in your code. And sometimes they get really long and they get really confusing. And it's helpful to know how to navigate that and simplify it down or know what cases make it true or not. So very useful to programming. And the other joke that I like to tell is you actually get to learn that 1 + 1 is 1. So 1 + 1 is 2, 1 + 1 is 10, but now actually 1 + 1 is 1. Well, in Boolean language, that is. So that's Boolean algebra. And then the topic of the fourth contest on all levels is graph theory. So graph theory was famously started by Leonard Euler, the mathematician, when he was in the city of Königsberg, which is a city that has a lot of different bridges. And Euler wondered to himself, well, can I run around the whole city and cross every bridge only one time? So maybe I cross here and then here, and then you kind of go like this. Oh, well, now I'm stuck here and I can't cross this bridge without, crossing any other bridges back. So I'm going to pose a challenge to you. I'll give you maybe a minute and a half or something. Does anybody here think that they can do it? Think you can cross all of the bridges only once? You can start anywhere. You can even start on the island. Chat me if you want to try. I'll let you annotate. All right. Yeah. I'll enable annotations if you know how to do it. Give it a try. See if you can figure it out. You can also, say what order the numbers you would cross the bridges. They're maybe a little hard to see. So that's close, but it doesn't look like you have crossed bridge number 2 in that case. So yes, anybody else want to give it a try? Give you 30 more seconds. So yeah, you go like this, and then, well, you cross 3 and then like that. Oh, but we forgot about number 4. Well, it turns out after banging his head against the wall for a really long time, Euler decided that it's actually totally impossible. You can't do it no matter how hard you try. And it really started this idea of graph theory. And so graph theory studies a graph. And what a graph is you might think of it like a bar graph or a line graph. But really, a graph in this case is like a bunch of dots that are connected by lines. So kind of like what we have up here. And so you could represent this kind of as a graph by, writing each island kind of like as a dot and connecting it each time there is a bridge. So it would look, I guess, like this. And studying basically this. And it's useful for representing like networks. So maybe like, a cellular data network, maybe, or a satellite network, or, maybe what cities are connected by airplanes or trains or roads or something like that. And so it's actually like very useful, not just in computer science, but kind of just across the board. Graph theory is like really very useful. And some of the stuff that we learn is, how to count like how many loops there are, how to count like, how many paths there are. And even we learn about traversability, which is basically saying, when can you do something like, under what circumstances can you cross all of the bridges, and under what circumstances can you not cross all of the bridges? So you might even learn why it is that it's impossible to cross all of the bridges in Königsberg. So that's graph theory. And those are all of the topics that were basically present on all of the contests. And then after that, there's some other topics that are like only present in middle school and above that I will go over, and I will take less time doing it. So the first one is recursive functions. Oh, I see. Oh, wait, I think that's old. Never mind. Recursive functions are basically functions that reference themselves. So what do I mean by this? Like, or maybe I should say like an algorithm that uses itself. So maybe if you want to check if something is a palindrome, like if it's itself spelled backwards, maybe you could say, check if the first 2 letters are the same, and then erase them, and then see if this is a palindrome, right? If this is itself spelled backwards. I guess I didn't maybe explain that as best as I could have, but I don't want to spend a ton of time doing it. But basically, think functions that reference themselves in some way, or processes that talk about themselves. And this is super useful in programming. We do it all the time. And you learn about like how to evaluate these kinds of functions and just how to deal with them. So that's contest 1, middle school and up. You might also learn about bitstring operations. So this means you do various math with strings of bits like this, like binary, but not necessarily adding and subtracting. You learn operations like, someone said that looks like the triangle you get when you circle all the even numbers in the Pascal triangle. It is. That's the Sierpinski triangle. That's a really well-known phenomenon in combinatorics. So good on you for knowing that. So yeah, you do operations with strings of bits. Things like and, or, and not operations, and shift and circle applications. And what all of that means, I guess maybe I don't want to get into all of the details, but it's all stuff that actually really comes up when you are doing very low level programming. Like if you're writing like a chip, if you're like creating like a computer chip, or if you're trying to understand like how your computer works at the lowest level, it actually all boils down just to these guys here. So it helps you to get a better understanding for that. So that is bitstring operations. That's contest 2, middle school and up. And then the third one is data structures and algorithms. So a data structure is basically a way of representing data or storing data on a computer. And there's several different ways of doing this. Some common ones that maybe you've heard of are like stacks or queues, or binary search trees or stuff like that. And you learn basically how to store and how to remove data in ways that are like organized and just help you to process all of your data. And this is super useful in software design, actually, because you know, software uses tons of data and you have to figure out how to manage it. So that's that. And yeah, so you learn about those data structures. And then contest 4, junior and up, you do digital electronics, also known as logic gates. And a logic gate is basically sort of like a little device where you have 2 wires that go in and 1 wire that goes out. So for example, this kind of little device would be called an AND gate. And what it means is you have 2 wires that go in, and if both of the wires are on, then the wire that comes out is on. But maybe if one of them is off, then the wire that comes out is off, kind of like this. And it basically is a way of doing Boolean algebra with wires. Although actually, like the way that we write this down on here, this is actually like a physical representation of literally how you would design a computer chip. So all of like your adding machines on your computer, or your subtraction, or your things that do and shift and stuff like that, it's all little circuits that are a lot like this. So it's useful for that. And if you've ever done Minecraft Redstone, this also might sound familiar to you, you know, AND gate, NOR gate, XOR gate, you know, all of that. So you get to do that, but with real live math on a contest. So it's digital electronics. And then I guess I also want to talk about, just briefly, I'm going to go over, oh, I forgot about this slide. Reading code is also on the middle school and up. So they're going to give you some big thing of code like this, and you have to say what it does. It's really not that hard to do. You just understand code that other people have written. This is like more complicated than what you would get on a contest. And it's just generally a good skill for programmers to have. You know, you should be able to read other people's code and know what it does. So yeah, those were, I guess, the topics for the elementary and junior written contest. So if anybody has any questions about those, I will give you a minute or so to ask. Otherwise, or I guess not a minute, I'll give you some time to ask. Otherwise, I am moving along. So I also just want to mention briefly the topics that show up on the high school contest. So contest 1 is actually just the same as middle school. Contest 2 uses the Lisp programming language, which if anybody remembers from before, it's a language that uses entirely prefix notation, which means that you write your math like this, which is, you know, kind of strange, but you know, the people that designed it really liked it. And Lisp is actually really helpful for writing AI programs, is what you hear these days. Regular expressions are on the 3rd contest. A regular expression looks like this, and it's basically used for matching strings of some kind, or you know, searching in a database for some kind of word that matches some format. It's useful basically for like database searching and checking input format and stuff like on the website. So it has its own set of uses. And then on the 4th contest, you would do assembly language. So the assembly programming language is like, it barely even counts as a programming language. It is literally just like machine code, but it's not ones and zeros. It's just like words. So it's like a super low level coding. And to be honest, people don't really code in assembly much these days, but it's actually very helpful just for understanding how your computer like does things at the lowest level. You really get to see what all of the different like steps are, you know, that your computer will go through to do various things. And so I honestly find that it's very helpful just for me when I'm programming, because I know what's going on. So these are the various topics that you might see in high school. And then the programming contest, did I make a title slide for that? Oh yeah. So there's also the programming contest. So I talked before about how that's all in Python. And the format for that is there's going to be lots of like algorithm questions, basically. So yeah, lots of questions on like, how do I write an algorithm or process to, turn this input into this output? Or how do I turn, this data into this, thing that I got out of the data? So that is like important to know. Is we actually get a lot of people who want to do the contest, and their Python experience is mostly like with Turtle or with like making little games or stuff like that. And I love Turtle and I love games. It's how I got my start. I mean, well, not Turtle, but I still make games to this day, right? I'm a very big fan of it. But it's just not exactly what you're going to be doing here. So that's just something important to note if you're thinking about participating in ACSL. And mostly what we focus on, the contests that seem to use a lot of for loops, while loops, strings, and lists are kind of the big topics that you see a lot of. So, rather than going into more detail, I actually just grabbed a couple sample questions for you. So this is like, I guess, one of the easier questions that you might see. So this gives you one input, which is an entire sentence, and you have to find out, how many letters are there, how many vowels are there, how many uppercase letters, what is the most frequent letter, and what is the longest word. So if my sentence was, I guess I'll just choose something very boring, like, I am in Wheaton, Illinois. That's where I live. Then you would say the number of vowels is 1, 2, 3, 4, 5, 6, 7, 8, etc. Right? And the longest word is so it would probably be Illinois, but maybe I'm wrong, and that would be embarrassing. Yeah, and so you would have this like in some variable, and you have to use code to find this and output it. And the way that it would be graded is they give you one basically sentence, which would be this, and then you need to output in certain ways the answers to each of the parts. So 25 goes with the number of different letters, and so on and so forth. So that's like one type of question that you might have to do. Another question, so this one's a little bit harder, is called the number transformation question. And this one, you just look at it and you're like, oh my goodness, what is it even saying? Basically, the idea is, so they give you some number, which you call it n. So 1, 2, 3, 4, 5, 6. And we have a number called p, which is 12. And we have a transition number, which is called d. I'll not make this 12, I'll make this 2. And there's a couple different cases, but basically what you have to do is turn n into some other number. So it says if the pth digit n from the right is 0 to 4. So the second digit from the right would be 1. Let's make it 0 to 4. I'll turn this into a 1. So now, so this is the second digit from the right. And then we need to replace it. So then we have to add d to it. 1 plus 4, so d is 3. So sorry, 1 plus 3 is equal to 4. And replace, so we replace this with 4. And then we replace every digit to the right of it with 0. And so then this would be our final answer. And you don't need to understand exactly the whole process here. That's not the point. I just want to let you know like the kind of procedures that maybe you would do, right? So you're going to be sort of scrolling through strings like this, checking maybe what are the different digits. Maybe you're going to do some math with them, and then maybe you're going to alter the string in some way. So you're going to have to know how to do all of that stuff if you want to succeed on the contest. And the way that it would be graded is, they give you, so this would be like your n, and this would be like your p, and this would be your d, and 5 different times. So you have to pass 5 different tests, and then the answer would be like this that goes with those 3. So yeah. So again, lots of for and while loops. So scrolling through things, searching, checking different digits, and lots of strings and lists. So, you're going to be representing this number as a string. You're going to be swapping out some of the digits with other digits, and so forth, and doing some math, of course. So these are two like sample programming questions. And sorry, I feel like I presented this in such a way like the second question, you definitely can like wrap your head around it, but I went over it so fast because I don't want to, I don't want to take up the whole time just explaining this one question. But that's just, yeah, the kind of thing that you would do. You would be able to understand it if you spent more time on it, if you weren't able to now. So that's that. Anyway, so that's basically all of the topics that you might go over, programming and written. And so then just like really quick at the end, talk about how might you go about preparing for this contest. Well, it turns out that for the written portion, well, all of this information is really on the ACSL wiki. They have some tutorials and some sample problems for everything. It's a little bit sparse, though they don't have a ton of information for you, but they have some information for you. But what I would say is really more important, honestly, beyond like just doing sample problems is work on math in school. Even if it's not the same topics, your math skill, excuse me, is really going to help you on the competition. Especially algebra is what I would say. So we had some students in elementary last season who knew algebra and some who didn't. And the students that didn't know algebra did fine on 3 of the contests, but they really had some trouble, particularly on the Boolean algebra section. I mean, it has algebra in the name, so maybe you could assume that would be the case. But yeah, so just honestly working on math is probably the best way to prepare. The skill all transfers over. For the coding portion, just working on Python programming, particularly algorithm type problems, and particularly for loops, while loops, lists, and strings. Those are like your big topics that it tests you on a lot. Also data types, so knowing your strings, your ints, your floats, and how to, what their relationships are and when you might want to convert between them is another important thing to know. And of course I do work for a company that offers ACSL classes. So I'm obligated to say, we've got some great classes, if you want to take one, we've got them here. And actually you do need to be part of some official team in order to take the contest. So that's another fun fact for you. You have to register as a team. And whatever team you register for, they're going to be preparing you for these, they're probably going to prepare you for the specific topics as well. And so that's why I would also say like work more on math than other topics, because you're going to have to be on a team anyway who's going to teach you all this stuff anyway. I guess I'm getting a little off topic. So take a class. These are the main ways to do that. And then finally, just really quick, what does ACSL look like at Bay Coding Club? So first up, I would just talk about signing up. So for the elementary team, anybody can sign up. But do watch the math level. We do like students to, if they haven't taken the class Algebra 1, that's probably fine. I mean, most people don't even take that until middle school. I certainly didn't. But they should have some experience, ideally, with expressions like, 3x plus 2 equals 4. Like probably, we would want someone to be able to solve this sort of problem for elementary. But we don't have any official prerequisite. For junior, though, we do have a coding evaluation. The reason for this is the junior contest, those coding questions are like, they're really pretty tricky. And so we just don't have time to, train people from scratch with no Python experience up to the level of the ACSL contest, because, the contests are just pretty hard. And so we would expect that you have some amount of Python knowledge before taking the class. So we have a little evaluation that we give out just to make sure that you're up to speed, that we would ask that you take before signing up. So that is the junior sign up at Bay Coding Club. The classes, we deliver them over Zoom. So online I mean, I, lived 1,500 miles away from my whole team last year. I think more than that even, like 2,000 miles away. So that was kind of funny, coordinating that with the time zones. But yeah, all remote online. And we do lots of practice problems, basically. So we do teach you all the material from scratch. We don't expect you to have any prior knowledge of the written contest material, and we just practice it like a lot, basically. And I try to incorporate a lot of games into the curriculum whenever possible. I really try to have classes that are fun for people. That's kind of my philosophy. So that's how I like to do that. And then for the contests, we actually do take them together despite being over Zoom. What we do is we put every student in their own breakout room, and they're not allowed to leave the breakout room. So we do that. And that's just for the written contest, because that's like 30 minutes, right? The programming contest, well, I don't know if you remember, but you get 72 hours for that. And I'm not staying on a Zoom call for 72 hours with the whole team. So we do ask that people take that on their own time. But yeah, so that's what ACSL looks like at the Bay Coding Club. So I guess I'm kind of coming up on time here, but that is the end of that presentation. So the remaining time is, I guess, open for questions. Yeah, and before we open up to questions, I just want to say thank you all for coming out here. It was my pleasure to share all of this information with you, and I hope that you got something out of it. And yes, I'm here to answer whatever questions anyone might have.
Okay, hi everyone, this is Bay Coding Club Ruby Sun speaking. So if you have any questions related with the ACSL or the registration of ACSL, so you can open your Mac and you can just ask. Well, Nathan, from our registration form, we did get some of the questions that when the parents registration, so they wrote down. So may I ask it right now?
Certainly, yeah.
Yeah, sure. One of the parents said, ask a question. Her son is at the 6th grade, so she does not know which category, which division that she should register her son. So
great. Yes, so 6th grade can go to either elementary or junior. Both are allowed. Which one you want to do really is at your discretion. It really depends just on, first off, how advanced you think your student is along in terms of their ability to handle math problems and programming questions. And particularly, I think it's important to know where they are at in their programming level. If their programming isn't super strong, maybe put them in elementary. But if they are actually a very strong programmer, then maybe put them in junior. So either is fine, but just, I guess, use your discretion depending on what level they're at. And we would be more than happy to answer any questions if you have any specifics about a student that you want to know. Or like, I can't give you a more detailed answer without knowing the details of a student, but if you want to have us talk or interview, or you want to give us any info about your student for a recommendation, we'd be happy to provide that.
All right, thank you. Yeah, so if this parent is here, and then you can just contact with us and do the evaluation. So we're willing to help. Thank you, Nathan. So there's another question is, you mentioned that the elementary team need to know some of the Python. So what level of the Python you recommend them to learn?
Oh, I'm sorry. I think that may have been a misconception. Elementary does not need to know any Python.
Okay, all right. So yeah, so they don't have to do the programming part, or
No.
they need to? Okay.
Yeah, no programming for elementary, but there is programming for middle school, junior. Yes.
Cool. Okay, so there's one very special parent ask the question is, so I don't know if you remember him or not. This parents did send her son to do the evaluation, but turns out I think Alex Wei also think he's not qualified. I think especially Alex Wei think he's not qualified since the case has already went to the 8th grade. And the parents are insist they attend for the junior team. So do you have any suggestions for this kind of situation?
So a student that is not qualified to take the competition?
Yeah, so according to the evaluation questions, yeah.
Oh, certainly. So yes, if you can't pass the evaluation, don't sweat it, because the contest will always be around for a few more years, especially if you're in 8th grade. So from that, I would recommend really work on Python, I think would be the thing to do. Take some Python classes, get sharp with your skills, and then you could always take the contest the next year once you're ready.
All right, thank you. Yeah. Yeah, there's another question is for the ACSL junior team. So is there any Java learner count, or they should learn the Python from the beginning?
Okay, so I would say that, yeah, the contests are usually taken in Python, but if you do already know Java and you're even pretty good at Java, actually learning a new programming language is not nearly as difficult as learning a programming language the first time. A lot of things will look familiar. And so probably, you would want to switch over to Python, but it wouldn't necessarily be too difficult to do so.
All right, thank you. Another parents ask, his daughter attend last year's ACSL elementary. Turns out she does not get good scores. So can she do it again, or she should move to the next level? Because I think his daughter is in 6th grade.
So yeah, what I would have said is, yeah, it depends on the age level. And honestly, it really depends on the student, right? And what they're looking to get out of it. I mean, if they want to take an easier contest, I mean, there's really no reason why they couldn't take elementary again. If they're looking to, do something that's more challenging for them, they could do a new one. They could move on to the next level. I think programming level is really an important thing to decide, because there isn't programming on elementary, but there is on junior. And so if you're not a strong programmer, I would probably really recommend you take elementary. But beyond that, it really, I think, just depends on what it is that you're looking to get out of the contest, honestly. At the end of the day, I mean, your college applications aren't going to be looking at this contest that you took when you were 12, right? And so the scores aren't really like that big of a deal in themselves. It's more the process of the studying and the trying that's valuable. And so it's really just what it is that you're looking to get out of the contest. Yeah.
All right. So as I understand from your answer, that means they can retake it or they can move on, right?
Yeah, they can retake it or move on. It just depends on their preferences.
All right. Thank you. I think I'm done with the registration questions from our registration form. So is there any questions that came from the Zoom or from Clubhouse? If anyone has any question from a Clubhouse, you can raise up your hands. I'll just let you speak. For the Zoom audience, you can open your mic and ask directly. And the chat, there's someone has some questions at the chat. On the website, when it says 550 for ACSL contest 1, does that means it is the class but run 2 times per week on schedule, turns evening and Sunday morning? Oh, on our website, Bay Coding Club, yeah, we do have 2 times a week. Yeah, for how many times, Nathan? 10 courses before the contest?
Yes, there are 10 courses before the contest. And also that tuition includes taking the contest with us as well.
Yeah, it is already included, the registration fee. Is that answer your question, Kimai? Okay, all right. Any other questions?
Oh, I think that actually might be for the previous one. It is certainly not too late to sign up. You definitely can still sign up.
Yeah, maybe they get the wrong information. Yeah. Sumai, can you just call us by the number that we provide on our website, and then we can do the answer to you, Kimai. I think you get the wrong information since it's not the time on Sunday morning.
Yeah, I think that's the one from last year because we had it Thursday night and Sunday morning.
Yeah, the last year one. Yeah.
Yeah. The contest is going to start up, I believe, in November sometime. I don't know the exact date, but around Thanksgiving break is when it would start up.
After that, yeah. So we'll have the information on that, so you can give us a call, or we can let you know exactly the new information ones.
Yes. So usually what we do is, depending on how big the class is, we actually coordinate the class schedule with the people who sign up for the class. Yes. Yeah,
I think the first week that we get started.
Yeah.
October first week. Yeah. So Kimai or Vivian, you can just let us know your information, and then yeah, as soon as you can contact with us. Yeah, because we're gonna start the coaching class soon. I think very soon. All right. Any other questions? All right. I think is that all? So I think if you have any other question, you either can email us at info@baycodingclub.com or just log in our website and call us. That is the quick way that you can get the information. Okay. Any other questions, comments for today? Clubhouse? Oh, okay. All right. I don't think people have questions, Nathan. So you want to make very quick takeaways for today's ACSL introduction?
Yeah. So, I mean, I guess the takeaways are the ACSL competition is, a programming competition for students all ages K-12. The elementary, if you're in elementary school, you'd probably take the elementary division. If you're in middle school, you probably take the junior division. Both of those contests involve math related to computer science. The middle school one also involves coding. There are 4 contests which you take, which cover various topics that are different from one another, but the same every year. And if you would like to sign up for this competition, feel free to contact us. Elementary, really anyone can sign up. For middle school, we would like to see some amount of prior programming experience, and we have an evaluation to help you with that. And I think that's basically the main takeaways of today.
All right, thank you, Nathan, for today's presentation. And I really like Nathan's last time in the contest, and he told our team members the sentences is like this. This is a contest. Yes, it is a contest, but it does not mean if you get the results bad, it does not mean you're a bad person. So it means just a contest. So I believe the contest is contest. So the most important thing is that we can learn something from the contest, right? So from the competition. So as our slogan said, change the world by doing good. We want you to be creativity instead of memorize something. So this is the big advocacy from our Bay Coding Club. So wish you all have a good time and find yourself and learn something from the competition, ACSL. So thank you all for today's presentation, and thank Nathan and our colleagues, Tina, Yixing, and all of you here. Thank you so much.